question 15. And I'm gonna talk you through this one because there's a lot going on here. So we have this biologist. He has recorded the number of worms. So this is 0 worms, 1 worms, 2 worms found in a 1 foot square foot of soil. And this is the probability that he had 0. So his 0 worms 5% of the time, 1 worm 6% of the time, 2 worms 18% of the time, 3 worms 35% of the time, and so forth. And then the G stands for grubs with the same idea in a square foot of soil. And this is how many, and this is the probability of getting that how many. All right, and so he's saying they're independent, right? They're not impacting each other. That's important, or we couldn't use these formulas. And that we want to find the mean and the standard deviation. So when I want to find the mean, this is the definition of expected value. And you can think of this a lot of like an average, right? We're going to multiply how many times the probability of getting that plus how many times the probability of that. And that's very much like finding the average of some value, right? So, and we're going to do that for each of these. Right, we can make this definition smaller. We're going to do that for each of these. And then we have to remember that if I have 2 random variables, it's okay for me to add them, right? Because I'm putting worms and grubs. I have the same space. So if I find their expected values, I can add those 2 up. So let's see what that looks like. I did that 0.05 times 0 plus 0.06 times 1, and I get all the values, 2.98. And I do that here for G, right? And I can add those 2 together. So 2.98 plus 2.3 means that I have on average, my expected value is 5.28 grubs and worms per square meter. And that's good because I have that as a choice, right? So C, D, and E all have that choice. Now, when I want to find the variance of a random variable, and remember, the standard deviation is just the square root of the variance. That's something we've had from before. I have to take each value minus the mean, the expected value, square it times the probability. That's what each of these means. The second value, so 1 minus the mean that I just found, square it times the probability. The third value, 3 minus the expected value squared, probability, and I need to do that for both worms and grubs. So I have that worked out here. Variance, there's the probability, 0 minus the mean that I found, squared plus, and I switched, it doesn't matter whether I multiply at the end by the probability or the beginning. All right, and I find that value for W and that value for G, the grubs. So I have variance of the variance of worms and the variance of grubs, and variance is also additive. So I can say 1.4596 plus 1.33 is 2.798, but I need to be careful because this is the variance and I have to take the square root to find the standard deviation, and then that gives us choice C. So let me know if that helps you.